Hello everybody, thanks for joining me again today. We'll be working on drakon render again. Let's switch to the code view. I hope everybody had a lovely weekend. I'm excited to be back. The plan for today is to continue working on this function that we started last time that links valent points together. And for those of you who don't remember or missed this session, when we inject new valent points like this, we do not link them to their parents. We don't link them to their dependents, so they are floating in a void. And it's still useful to render them like that for the purpose of this markdown file. But the rendering engine won't actually leverage those newly injected valent points until we link them with their parents and dependents. But as I was thinking about this during the weekend, it occurred to me that maybe wanting to link them in this current representation, meaning the list of lists of icons, let's find that function, link, is not the best idea, simply because if, let's find this here, if I link v1 to become a dependent of, say, what would be a good example here of, let's for the sake of the argument say v1 is just under icon 7. If I link v1 to be a dependent of icon 7, and I also have icon 7 here, and let's also pretend that v2 takes the place of icon 9, I would have updated icon 7 here, but this icon 7 is a different reference. It's a different object in memory. So I would have to consolidate those icon 7s somehow. So what I'm thinking of doing right now, and because this is markdown, I can edit this on the spot by hand. Let's hide this. What I'm thinking of doing right now is those new valent points. I don't really have to give them a name right now. Okay, and this dummy dependent is just injected for the purpose of just proving to myself that I can do it, and just to maybe trigger some ideas. I don't really need to give them names immediately right now. I can do it at some later stage, and I can also remove that dummy. The dummy is a result of just me experimenting. So what I'm thinking right now is that the markdown here is good enough, I feel. It, or at least it is good enough for now. It illustrates what it was designed to illustrate, all the various paths and how many valent points each path would need. I think I'm pretty happy with this, even if the valent points are named 0. Where I think we should go with this is put a pin in this markdown file for now. I'm, again, pretty happy with this as it is right now, but instead, as we link those icons together, we can do it not in terms of the list of paths, but in terms of all icons. So that if you have a link between, say, valent point X to a parent and to dependents, you don't really have to worry about consolidating all pre-existing icons together. When I say consolidating, you remember those different paths with different dependents. Yeah, we want to avoid that problem. So I'm thinking we went from, if you maybe remember, we went from a collection of provided icons like this to a collection of paths like this, in order to balance them slice by slice. Now it is the time to go from the collection of paths to collection of icons again, to consolidate all icons so that we don't have any duplicates, to inject valent points into the type that we started with. And I think it makes the most sense to me, having spent a little bit of time during the weekend thinking about this. So the link function is probably going to be renamed to something else. And I don't have a good idea for a name yet. So let's call it an ABC classic. And it will have this exact function signature. We'll go from all the possible paths with all possible valent points to just a collection of icons that are unique and are ready for the next step of the process, which is the laying them out on the 2D plane and also producing a diagram out of them. So this is pretty exciting to me. I have a little bit of time today, so I'll be back after a short break with a fresh cup of tea or coffee, and I hope you stay with me and enjoy some Haskell and drakon. It should be fun. I'll be back in a sec. All right, it looks like OBS is back again. I'm back with a fresh pot of tea or a cup of tea, and we can proceed. So, before we start implementing this function, I want to sort of make life a little bit easier for myself. And instead of using lists like so, I want to use a map. Simply not to worry what to do with duplicates. And for now, yeah, maybe just leave icon as a key and icon as a value. So we want to remove this link function, print bpaths as we wanted to do, but bpaths should later on be executed. Should be leveraged in with that new function, ab bpaths. Not balance, bpaths. All right. So here, at this stage, we have all icons correctly named. Remember, the process of giving valent points their names takes place during the balancing process, so we're good. So all we need to do is to fold, or just to keep folding. I don't really have to specify this, do I? So this, if I remember correctly, this function inserts an element into a map with a function that determines what to do with its value, I believe. We'll be looking this up. So here we go, fold R. So here, we still need to use fold because we should have access to the previous icon. So here we shouldn't be touching this. You know what? Let's take it maybe step by step. I think we're juggling too many balls here. Let's call it paths. So we're going to turn only the first path into a map. Oh, I think this function is not needed now, and it's just causing compilation errors. Let's run it. Oh, goodness. Let's try to unpack it. So we don't need all of these now. From list. So, sorry, that's just the first pair. Okay, we can trust it. And the last name is 6. Perfect. So let's see this balanced thing. Is it this? I believe so. Simple diagram 3. Simple diagram 3. Yes. Right. Sorry. Right. My music switched off and I can't really function without it. So we can close the notes. Don't need those. The map works fine. Now, in order for us to be able to debug this, this is probably not very sustainable, that type. Let's do... Let's do this instead. This should produce something that we can actually troubleshoot. 1 and 10. All right, so now we have the first row. Let's try to embed this fold into or not, maybe not. So what we want to achieve here is to not only embed the row, but also we don't want to translate the row into the map, but also to link all the new icons together. And in the first sorry, here. In the first path, we don't have any new valent points. So let's do last. And that will serve as our sandbox experimentation case. So yeah, we have new, we have v4. 7 depends only on 8 and 9. 7 has only 8 and 9 as dependents. 9 has only a 10 as a dependent, even though the next one is v2. Okay. Yeah, you can also see it here. 9 has only icon 10 as the dependent, which is here, while in fact v2 is its true dependent. So what we have to do here is to connect. We have to update the dependent or add the dependent. Let's see if this can be formatted. Yeah, and it looks much better. So first of all, maybe you remember from the last session, we started with a fold R. And this, for the time being, let's pause, because the accumulator here is going to be a list. Why? Because we should always have access to the last inserted item in that list, because that last inserted item will have to be dependent of the item that we are inserting right now. I hope it will all make sense in a second. So here we replace this with just an empty list. And here we do this trick. Instead of icon, we actually have to check case. there will be no changes, but otherwise, and bear with me, it just looks similar, but it will soon enough change to an updated icon, which gets a dependent injected in it if a dependent does not exist yet. For now, though, I think it should work if it compiles. Sorry, excuse me for a second. All right, I'm back. Let's see. This compiled. Let's run it. So we get a list of all icons from the first row. That's good. Now, what we need to check sorry, not check really, but update dependent. I don't think we need to necessarily clear dependents. Simply because we will only add dependents if the icon type is a valent point. So you know what, let's format this. This is a very delicate piece of code. For now, this is not correct, but it should compile. I'm mainly interested in how this should be indented. Something like this. Okay, I can take that. So the last icon. So we know that if the last icon is a valent point, let's see. And again, this is not correct, but I just want to provide a scaffolding for this new logic. Oh. Oh. So we don't have to use this, that's good. Now, if it is a valent point, we know that the parent icon should get the new dependent of that name. So add dependent name and we have to insert that. If I didn't miss anything. Sorry, the order should be reversed. First goes the icon, and the second goes the dependent name that needs to be added. Oh, that's fine. We'll deal with those hints later. This is how it looks formatted. And I'm very curious to see how it would look like. And let's rename this to the last row. So what we're expecting is a list where this one has no, that wouldn't work, because in our case this 10 needs to be removed. But the good news is we can already see it here. The dependent named v2, which is this, got injected into the list of dependents of icon 9. That's good. So in v2 we should have one dependent that's v4. And v4 won't have 10 as a dependent, and that's a mistake. v4, it doesn't have a 10, and it should. So we need a function. That checks whether any of the icons provided is a valent icon or a valent point. So we'll have two icons. So we'll need equality here. So by doing this, I'm hoping for a compilation error that will tell me what kind of type class I need to implement. Now let's do some Googling. Sorry. This looks okay. I'm not sure this is the best way to do this. Let's see this hint here. Not exhaustive, okay. But it compiles. Something like this. You have a headline. address. And valent point. This should be exhaustive now. Yep. Or we can probably replace this with a list, but we won't need a list here. So after a quick detour, we can go back here. I hope this works. Doesn't look very appealing, but let's see if we can resolve it. Redundant bracket, but let's format it first. Now it is very obvious why it is redundant. Okay, so this should fix the problem where 10 is not a dependent of 4. Let's run it. Four has one dependent, and that's 10. Cool, that works fine. Now, now, it would be nice to emulate an environment where we have access to the map of icons. And we not only add the new icons to the accumulator, but we also update the icon map. but it would have to be added to the accumulator. Let's see if I can name a variable like that. It looks like we can. So this accumulator will become two parts. One, all icons, and two, a map. And as the time progresses, we'll remove this first element of the tuple. So this will not compile. Let's not worry about that map. And that map, I will leave it empty for now. That will be the first part of the tuple, or first element of the tuple, and the second element of the tuple would be just map. Oh, we need the and a keyword. And indent it some more. Apologies. This needs to be a tuple. Let's run it. So the results should be exactly the same plus an empty map. Perfect. Now, what we want is we should pretend that that map is really the map from the outer fold that we will add here later, and we should inject items to it. So data insert with Should this work? Still not the prettiest thing to look at, but at least it's formatted. And now we expect only one item, which is icon number 10 here in the map. Okay, that's good. Now, the reason I added this new icon is because it will also participate in the map here. Here we need to use the updated icon, which is new icon. And now what we should see is we're not really interested in this first element of the tuple anymore. We only want to see the map. And the map is 1, 10. Okay, interesting. Oh, well, the icons are not guaranteed to be in order now because it's a map. But we should expect some common expected sites, like icon 9 should have 2 dependents, v2 and 10. v4 should have 1 dependent, that's 10. And v2 should have 1 dependent, that's v4. Let's see, where is v2? v2, yeah, it has v4 as a dependent. Okay, so this is working. So we have very good foundation set for an outer fold. So it's a good thing that I decided to take it step by step, because I would probably break my neck trying to implement this from the scratch all at once, both folds. Only now we can replace this last row with a fold. So this is our outer fold. And in that outer fold, this time it's going to be a fold L. Now this accumulator can be a map. Let's call it the map. We're iterating over or folding over rows. So this last row will become a row. We'll format this later. So now, map we already have. And the starting element here will not be empty, it will be the map. the starting value of this will be datamap empty, and we'll be iterating over paths or folding over paths. So here, the map is what we're after. Now, row. This is the row. Fingers crossed. No, and now we do not return the tuple, we return a map. And now the second is no longer needed. I believe this can be simplified, so that's fine. All right, let's get to it. But before I paste this into the notes, let's take one final look at this markdown and sort of set our expectations. I'm expecting 6 icons to be updated. 8 v1 v3, 9 v2 v4. Okay. That's one. No updates here yet. No updates. Oh, first update is here. We have v1 at 10. So that 10 is incorrect, but we'll deal with this later. This is correct. v1 has one dependent, that's v3. v2 has one dependent, that's v4, and I believe, and that's 10. And v4 also should have 10. Perfect. That's it. So the algorithm is working. Now, there's only one thing left to do here. This is done. This is not done. And remove icons no longer listed as dependents. But I think we'll do it during the next session. For now, I'm pretty happy with the progress. During the next session, what I would like to do is to remove dependents that are no longer dependents after the valent point got injected. And I will need a little bit of time to think about a reasonably clever way of approaching this. For now, I would like to draw a line here. Thank you all for your patience with me. And yeah, I invite you to watching another episode in the series of me programming daily and working on Drakon. It's a lot of fun. And yeah, I wish you a fantastic Monday. See you next time. Bye.